Good morning, students. My name is Mohammad Azim, working in the Sri Ratna Group of Institutions as a assistant professor in the mechanical department. Today, I would like to tell a subject on fluid mechanics. So, before going to learn this subject, we should know the prerequisites and the course objectives of this subject. So, first I will write the prerequisites of the subject. So, our subject is fluid mechanics. In this fluid mechanics, if you want to know the fluid mechanics subject, you should know the prerequisites. What are the prerequisites here? Prerequisite subjects are, you should know the engineering mechanics. You should know the engineering mechanics. And along with the engineering mechanics, you should also know the mathematics. You should know the mathematics. That are the two subjects which are very helpful while doing the problems in the fluid mechanics. Coming to the course objective, what are the course objectives we have? Course objectives. See, what are the course objectives you will see for studying the fluid mechanics? The course objectives you can see you will understand, the students will gain the knowledge on the types of fluids and types of the flows, and so let us see the types of flows are steady flow, unsteady flow. You can know that. Similarly, what are the properties are there? The surface tension, capillarity, all these we will see with the real-time applications. So student will gain the knowledge on these types of flows and types of flows and whatever the properties are there, you will see. And one more thing. Along with that, we can also see the applications. What are the real-time applications like bend in pipe? All this will be studied in the course objective. Now, we will jump without wasting the time the definition of the fluid mechanics. So fluid mechanics. What is fluid mechanics? So before going to the fluid mechanics. So I am dividing into two parts. One is fluid and mechanics. To explain the definition of the fluid mechanics, I am dividing into two parts. One is fluid and another one mechanics. So first we will discuss about the fluid. So what is fluid? Any substance which can flow, or any substance which has an ability to flow, is nothing but fluid. Any substance which can flow is called fluid. So see here, in this I have two things. One is substance and flow. So what is meant by substance? Substance is nothing but it's a matter which is having a definite mass and it occupies some volume. Along with that, it is a tangible. It should be tangible. So what is substance? Substance means it is having some matter. So matter means it is having some finite mass. It should have some finite mass, the first one, and it should occupy some space, and the third one is it should be tangible. So what is tangible? Tangible means it should be any object which should have a physical field. The physical field is having for only tangible objects. So tangible objects. So we completed the word substance. Now we will go for what is meant by flow. So to define the flow, I am taking some xy axis. I am taking xy axis, x axis and y axis. I am taking x-axis and y-axis. Here I am taking the number of molecules. Let us say number of molecules are contained here. Number of molecules are contained here. Now what I am writing, the relative change of the position with respect to time can be defined as a flow. The relative change with respect to time can be defined as a flow. So I am writing here the relative change of position with respect to the time. So means, for example, my body is there, the air is coming inside and going outside. I am inhaling and exhaling through the help of lungs. So the whatever the particles are going inside and outside. So there is some flow is there from inside and outside. That is with respect to the time. It's changing. So that is nothing but the flow. Or another example, you take a glass of water and just you tilt it. It's like to start to give some deformation. Again you tilt it 0 degrees, what happens? Water will be flown to the downwards. So that is nothing but the flow. So with respect to the time, there is some relative change of position. From here, whatever the particles are there, here to here, it is displaced. So just now I explained air and the water are the good examples to explain the flow. Now here we have matter. So the substance is composed, the matter is composed of two things, two types. What are those? One is solid, another one is fluids. So we are discussing only on fluids. So matter is composed of two things. One is solid, another one is fluid. So fluid. So we are interested on the fluid. So what is fluid? Fluids are again composed of liquids and gases. So generally, if you see the perfect definition of engineering mechanics. So if you, even though you apply a small shear force on the liquid, it continuously started to deform. But if you apply the shear force on the solid, it won't deform. It will deform, but again it is regain its original position. If you apply the water of the shear force up to proportionality limit. See, I will explain here. So let us take a block. Let us take a solid block. This is the surface. I am taking a solid block. I am applying small shear forces like this. The shear force means it should be parallel to the surface, or it should be parallel to the body surface. So I am applying some shear force. Let us say small shear force. What happens after application of shear force or a big force? What happens? Whatever the solid body is there, it tends to change the position of the body up to proportionality limit. Up to proportionality limit is there. Again, if you remove this force, you will get its original shape, whatever the original shape. But coming to the liquids, take an example as a water. Take an example of the water. The water is there. Right? This is the surface of the water. Now apply a small shear force here. What happens? It started to continuously deform like this. Only. It will never regain its original position. So that is the difference between the solids and the liquid fluids. Now, after completion of this, we will see the second word, mechanics. So what is mechanics? Mechanics means we will study the forces and the effect of forces. In the mechanics, the second word is mechanics. We will study the forces and the effect of forces. The effect of forces on fluid. Is nothing but the fluid mechanics. So here, when the fluid is at rest condition, then the fluid is at rest condition, we can call it as the fluid statics. Similarly, when the fluid is in the motion, after application of forces, then it is called as the fluid dynamics. Again, this fluid dynamics again classified into two types. One is kinematics and kinetics. Or you can call it as kinetics as a dynamics. So this is kinematics and kinetics. See, in the kinematics, we will study the motion of the fluid only. We are not considering whatever the energies in the fluid. So we are not considering, we are not calculating. But here we are calculating the energies with the whatever the energies are there, we are calculating. That is nothing but the fluid kinetics. Now we will see microscopic approach and macroscopic approach. So what is microscopic and what is microscopic? Microscopic approach and macro. What is microscopic approach? In the microscopic approach, we will study only the molecular of a single molecular. Okay, we are studying only the a small amount of molecules. Okay, this is a micro. The micro name it equals a small, very small amount of molecules will be studied, or behavior. What are the behavior we are studying here? Coming to microscopic effect, we are here we are studying the summation of all particles or all molecules. Summation of all particles, or you can study the average fluid particles. We are studying the average fluid particles. Average fluid particles. Average fluid particles that can be studied here in the macroscopic point of view. So we are interested in the macroscopic only, macroscopic only. We are not interested in the micro. So we are going to study our total syllabus regarding macroscopic. In the macroscopic, so we are assuming one that whatever the distance between the molecules is there, whatever the distance between the molecules is there, whatever the distance between the molecules is there, they are very negligible. So what, there is no void between the two molecules. There is no void between the two molecules. There is always a continuous distribution of molecules. There is always a continuous distribution of a mass particles. That concept is nothing but continuum. There is always a continuous. Continuous distribution of a mass particles. Will they always continue? Because we are assuming that there is a no void, so no gap is there. No void is there, so we are continuous distribution of mass particles there. This concept is called continuum. Continuum. This concept is called continuum. So this continuum is applicable for only few fluids, not to every fluid. It is not applicable. So what are the fluids we are applicable? That is fluid applicable to some we are considering some dimensionless parameter. The dimensionless parameter is something but Nunsen number. So what is Nunsen number? What is Nunsen number? Nunsen number may be defined as it is the ratio of mean free path to the characteristic length. It is the ratio of mean free path to the characteristic length. So mean free path is denoted by letter lambda and this is denoted by small capital L. So Nunsen number Ku. Nunsen number is denoted by Ku. This is denoted by mean free path. So what is meant by mean free path here? The mean free path may be defined as you can say the mean free path. When let us take an example of the room. Here number of particles are there. So number of particles are there. One particle will or one molecule will collide with another molecule, and the another molecule will collide with the other molecule. So how far? So how much time it will take to collide to the particles? Because why the particles will collide in the liquids? Because there is no much intermolecular forces are acting on the particle. Will like compared to the solids. So that's why they will collide. They will travel and they will collide. So this collision is nothing but two consecutive collisions. Let us say this is the molecule 1, this molecule 2, this will collide like this, and two will travel like here, and 2 will collide to 3. This is the consecutive collisions will happen, and here I am measuring this distance. Whatever the distance is there, this distance is nothing but the mean free path. The distance is nothing but the mean free path. So we completed the mean free path. Then what is the characteristic length? So this whatever the fluid particles are, this is the solid boundary. Here the liquid surfaces are there. Here the liquid surfaces are there. So we are analyzing these collisions and whatever the forces are there. Here this length, about how much length this collision is taking place, that is nothing but the characteristic length. So this is the definition of Knudsen number. So what the Knudsen number should be, what some value should be there. So length by length you will cancelling. So there is a dimensionless parameter here. So here Knudsen number should be 0.01. It should be less than 0.01. Then it is applicable that there is a no void, there is a no gap. So you can see the continuum concept. So for this Knudsen number, here you can see this Knudsen number. Let us take a solid boundary. The solid boundary. These are the different layers of the fluid. But in the bottom, whatever the bottom layer is there, which is sticking to that surface, here whatever the velocity of the fluid is there, the velocity of the fluid is u equal to 0. They will adhere to each other, because adhesion means sticking property. Stickingness property will be there. So they will adhere and the velocity will be 0. If Knudsen number is going to range between 0. Let's say between 10 to 0.1. It is ranging from 0.01 to the 10. Then there will be some slip factor will be considered. So here whatever the u is 0, velocity is 0 is there for 0.01 value. If it is going on increasing the Knudsen number, then whatever the velocity is there, the velocity will not be considered as a 0. So then you won't take the continuum concept. The continuum concept is not applicable for this. And this is an introduction class to the fluid mechanics, and I hope you understand. And so we covered these parameters, and thank you.